So the last idea we need to cover here in the basics of the probability operations is called conditional probability. And these probabilities, when you're asked these, they're phrased in a sort of curious way. So I want you to think about pulling a card up out of the deck. And the question I'm going to say to you is that card, I'm going to tell you that it's a non-face card. And now that you know that, I want you to tell me the probability that it's a club. So the way that's phrased is, what is the probability of a card being a club? So you draw it. I look at it. I know that it's a 9. What's the probability that it's a club now that I know it's a non-face card? Now, if we just think about the answer to that before we do any math, if I were to hand you a card and say, this is an 8, so we know that. It's a non-face card. This is an 8. What's the probability of it being a club? Well, it's either the ace of or the 8 of clubs, or diamonds, or spades, or hearts. So it should be 1 out of 4. That's the answer we should arrive at. So if we can try and bend this calculation and the notation to get 1 out of 4 as our answer, then we will have succeeded. So what is the probability of a card being a club given that it is a non-face card? So the way you write that is the probability of a card being a club given that it's a non-face card. Well, there's a formula for calculating this. The way that you're supposed to arrive at this numerically is to take the probability of it being a club and a non-face card and divide it by the probability that it's a non-face. So when you read these, the probability that it's this, given that, you notice that the non-face went in the denominator here, and the club and non-face went in the top. So if I were to do this, the probability of it being a club and a non-face, we already worked that out. That was over here, 5 out of 26. And the probability of it being a non-face card was 10 out of 13. Alright, now, you're going to have to get your fraction skills in order to work something like this out. I have a fraction divided by a fraction, so I'm going to write it this way. There's a rule you may have remembered from grade 5 where if you divide by a fraction, you invert and multiply. Well, 5 times 13 is 65. And 26 times 10 is 260. Now if we were to take a calculator and give that a try, 65 divided by 260 is 0.25. Curious. And that happens to be 1 out of 4, which is the answer we'd already arrived at. So this one is a bit tricky to wrap your brain around about what it's asking you exactly. So that phrasing, what is the probability of a card being a club given that it is a non-face card, is we've decided that it is a face card already. So I want to see, I'm going to use this as a tool, in fact, to test whether things are independent. If this is the case, if this and this are independent of each other, do you notice that this probability happened to match exactly the probability that it was a club? So if the probability of it being a club, given that it's a non-face card, happens to be equal to the probability that it's a club, then you've shown that those two things, being a club and being a non-face card, are independent events. They have nothing to do with each other. So I'm going to take this idea and I'm going to write it down as formulas so you have something to look at. Now, the way this is presented on Khan Academy is using conditional probabilities. So they would have asked, what is the probability of getting an 80 given that you took the bus? Now, to calculate that, you would have to do the probability of getting an 80 and taking the bus, and divide it by the probability of taking the bus. So if we just run quick through that calculation, 80 and the bus would be 23 out of 68. Probability of taking a bus was 43 out of 68. (23) divided by 68 is 0.3382. 43 out of 68 is 0.6324. .3382 divided by 0.6324 is 0.5348. That's the probability of getting an 80 given that you took the bus. Now, the way they presented it, hunting to see if things were independent or not, was to take this probability and see if the probability of getting an 80 was equal to the probability of getting an 80 given that you took the bus. So the probability of having an 80 average was 36 out of 68, which ends up being 0.5294. So if we compare those two numbers, the probability of getting an 80 given you rode the bus was 0.5348, and the probability of getting an 80 was 0.5294. Now if you look at those two things, this, if I rounded it to only 2 decimal points, would round to 0.53. If I rounded this to only 2 decimal points, it would also round to 0.53. So calculating it this way also provides some evidence that these two things are independent, because the probability of A given B is equal to the probability of A. So we'll check one more. We won't do all three because I think you get the idea. But if we tried to do the probability of getting an 80 given that you did extracurricular activities, we're going to work that out and then compare it to the probability of getting an 80. And if they match, there's evidence that the two things are independent. Now, we've already done this, so we already know that they're not. So let's hope that this calculation matches that conclusion. So probability of getting an 80 given that you did extracurricular activities needs the probability of getting an 80 and participating in extra divided by the probability of being in extracurricular. So being in 80 and extra is down here. That's 14 people out of 68. Probability of being an extracurricular was 22 out of 68. 14 out of 68, 0.2059. 22 out of 68, 0.3235, which gives us 0.2059 divided by 0.3235, 0.6365. That's the probability of getting an 80 given you were in extracurricular activities. Now, the thing I need to compare that to determine independence is the probability of getting an 80, regardless of whether you were in extracurriculars. So that is 36 out of 68 people. .4853. Now, these two values clearly don't match. So the probability of getting an 80, given that you were in extracurriculars, is lower or is higher than being if you had just checked the probability of getting an 80. So that's that thing there again, showing that it's overrepresented. If you did this, if you were in extracurricular activities, you are more likely to have gotten an 80 than if you didn't, or if we just take the general population. So if we were to do this again with the probability of taking the bus given you participated in extracurricular activities, I would expect that this number, the conditional number, would be lower than the probability in the general population. So that's how Khan Academy was testing for independence.